I'm a program manager on the OData team at Microsoft, and I kind of look after the OData protocol. I'm helped sort of drive that forward. We think about what's going on in the future and what we want to do next. So if you have any questions about that, you could probably come up and talk to me about it after the session, because we're not going to cover that today. The topic for today is building custom OData services using the best practices, and also we're going to do that in SQL Azure as well. But before we get started, I'm going to ask us basically a series of questions. Just kind of think of this as a little pop quiz to see if this session is going to be useful for you. Okay, now keep the answers to yourself, because this is really just to see if you understand what we're about here. First one is, do you know how to build a custom OData service? Okay, that's number one. Number two, if you did you know how to configure and deploy it? And of course, the topic of this session is deploying it to SQL Azure as well. More importantly, once you've done that, will it reach your audience, right? Like, there are different types of clients out there, and you need to make sure that you wrote your service and you configured it in such a way that it will reach those clients. So will it get to JavaScript clients? Will it get to Silverlight clients? This is pretty important. Are you going to share only what you want to share? It's very important from a security standpoint that you don't share too much information. And then as a kind of an afterthought, but hopefully you do it beforehand, are you planning for the future? Things are going to change. Are you going to take that into account? So here's why it matters. OData is the easiest way to share data on the web today over HTTP and allow people to query that data. If you do it wrong, though, and it's particularly if you put it up into something like SQL Azure, you'll be paying extra costs than you needed to pay. Okay, you'll be paying for extra CPU and extra bandwidth costs. We all know that the world is moving towards more and more important clients now. Well, sorry, the more and more important clients these days are the mobile clients and JavaScript clients. People are writing loads of applications in those things now, so we've got to make sure that our OData service will actually be able to be consumed from those. We know that the last thing you want to do is be responsible for your company being in trouble somewhere in the press for sharing too much data. We've seen some recent examples of that kind of thing, and no one in this room wants to have their career hurt because they did that. And then, of course, things change. Once you've deployed your service for the first time, it's going to change. You know someone's going to come along with some new requirements. So let's make sure that when we put our service up for the first time, it's ready to go and we can version it. Okay, so I want a show of hands. How many people in this room know what OData is? Okay, it looks like most people. Good. So I'm not going to spend a lot of time talking about OData, what it is today. I'm not going to give you much of an intro, but I'm going to spend about 10 minutes just covering that. And then we're going to dive straight into building a custom provider, and that will take, close to 60 minutes. Okay? So imagine you have a data source, and you want to be able to get that data out to some consumer somewhere. If you put an OData service on top of that, the first thing you get is you get access to that data over HTTP. So that means you can go through firewalls and things like that if people have configured the appropriate ports and things. So that's good. You also get a lot of reach. Okay? OData is a relatively simple protocol, and as a result, there are multiple clients out there for different platforms. If you want to consume your OData in your Android tablet or your iOS or your iPhone, you can. Or if you want to consume it in a web page via JavaScript, you can. The next thing is OData services come with some metadata. So this metadata allows clients to understand what the service is going to expose. This is kind of similar to WSDL if you're familiar with that. That metadata, clients can use that to generate classes that make it easier for developers to interact with the data. We also support two formats. Atom, which is essentially where OData grew out of. That is actually Atom Pub. Okay, and it's a kind of a minor extension on Atom Pub to support rectangular data. And then we support JSON as well, which gives us much better reach into the JavaScript world. I said before that OData kind of was born out of Atom Pub. Well, Atom Pub actually has a set of semantics that it describes to certain HTTP methods or verbs. And OData follows those semantics. Okay, so we know what it means if you go and get something. That's a query. That's retrieving some data, but it's not having any side effects on that data. Post would be an attempt to insert something. Delete, well, that's pretty obvious. And put is an attempt to update or replace. Okay, there are other verbs for updating as well. Patch for kind of doing a change where you're merging your changes into the results as well, into what's on the server. Next, we have a series of URI conventions. So the URI conventions allow you to predict, based on your knowledge of the metadata, what sort of URLs you'd need to write to retrieve, certain parts of the data. So, for example, in the first of those two queries there, we know that customers have orders. We know the URL for a particular customer is customers for, so we know we can just append orders to the end of that to get the orders for customers for. And we also know from the metadata that we looked at earlier that customers have a city property. So I can issue a query which will retrieve just the customers from Atlanta. And of course, because it's all over HTTP, all of this stuff can just be pushed up into the cloud, and you can put it into SQL Azure, and everything will work fine. Why would you use OData? First one is it's HTTP. HTTP is ubiquitous. We use it idiomatically. So we take advantage of all the HTTP isms. So, for example, if you want to retrieve it in a different format, use the accept header, which is the standard way to do things in HTTP. If you want to do caching, you use e-tags, standard way to do things in HTTP. If you want to get the concurrency tokens, know whether something has changed. It's suitable for devices because there's such a low barrier to actually consuming and creating OData information. You can do it just through JSON and JavaScript. It's very easy. It's incredibly simple to create an OData service. The simplest OData service that you can create is you could just take a flat file, put some JSON in it, stick it on a web server, and that's an OData service. Okay? That data could be consumed through Excel via Power Pivot, and that works just great. But of course, that wouldn't give you any query capabilities or anything like that, so you'd need to add some extra stuff to that. But of course, the protocol actually scales from right down to very simple to up to very kind of enterprisey kind of features. So you can do query, you can do projection, so to narrow the results and narrow the number of columns that you get back. You can do expand to get back more results with a particular item. So as an example, if I retrieved an order, I could retrieve back at the same time the order lines. You can do paging. This is both client-side and server-side, and we'll show you how to do that later on in the talk. But I think probably the most important reason why you would use OData is more and more we're in this world where people are creating web APIs instead of websites. And in order to create a web API, you need to seed your environment or your ecosystem with samples for all the various platforms that are out there. And there are not many developers that know every single platform. Okay? So OData actually, though, because it's a standard, there are multiple implementations on different platforms already out there that you can leverage. So you don't have to do that. Along with that, on the server side, we have loads of producers now. These are the people that are actually sharing their data through OData. A lot of the Azure stuff is shared through OData. There are Azure management APIs. Some of those APIs you can access through OData now. SharePoint you can access through OData. So if you want to get to the list data, you can grab it that way. Data Market, which is the kind of like the app store or the data store that Microsoft has got in Azure. That way you access the data there is through OData. Dynamic CRM, if you want to manipulate or query for customers and things like that, you can get to it through OData. Then there are third parties external to Microsoft that have done it, Stack Overflow, Netflix, a number of CMS providers. So a really cool one to look at would be WebNodes. They do some really nifty stuff. You can actually, kind of like you've got a page. Using OData, you can drill right down into the paragraphs in the page and access a specific paragraph in the page using the OData protocol. So that's kind of cool. SAP have announced about 3 to 6 months ago that they're going to expose all of their enterprise data through the OData protocol. So as you can see, this is changing a lot. And there are a number of Microsoft internal partners that I work with that are going to be pushing out OData services soon. Okay, so that was the introduction to OData. Now we're going to dive straight into building an OData service, okay? So what I've got here, while it syncs up, is a project that I've created previously because we don't have time to go through all of the steps necessary to set this up. And this project it's an Azure project. So what I did was I just went in and added a Cloud Windows Azure project. Okay, that created both of these. It created this Azure deployment piece, and then the website, which is going to be pushed into a web role. Okay, I've made some changes to that so that we've got something to start with. What I've done is I've gone into this in here and I've created an entity framework model. I did this using Entity Framework's model first. Okay, this model is really designed to capture people's web link favorites, your favorite URLs on the web. It has users and it has favorites. A user has favorites. Some favorites are public, some are private. And some users that are administrators. I've also got in my global ASAX some code to set up the database. So this is kind of like some seed data. And if we look at this, what it's doing here is I'm creating the entity framework object context. And then I'm going to just go and test to see if I've already got the administrator in the database. Okay? If I don't have that administrator, I go ahead and create a couple of users and about 5 favorites. Okay? One of the users is an administrator. Pablo is not an administrator in my database. And you can see that's pretty simple. And at the end of that, I just call save changes. Okay? So this is kind of this is my starting point. And if you're familiar with the entity framework, you can imagine that this is pretty easy to get to this point. And by the way, entity framework is by far the easiest way to create an OData service today, a read-write OData service today. What we need to do to create an OData service here is we want to add a new WCF data service. And you'll find that under Web. Scroll down, there it is, WCF data service. I'm going to call that my favorites service. And you see that generates some code with a number of things that I've got to do to make it work. The first thing I've got to do here is I'm extending a data service. In fact, I'm extending a data service of T, where T is the data source. That's where the data is coming from. And in our case, the data source is Entity Framework. Okay, so let's go find the object context. This is it here, this models container. At this point, I've got an OData service, and I've got it connected to a data source, but no data is being shared on the web. Okay? You have to explicitly choose what you want to share. So let's do that. If you look at this model here, I've got users and favorites, and I want to share both of those. If I show properties and click on favorites, you'll see that the name of the type is favorite, but the name of the set is favorites. So it's just plural. It might be different, but the thing I need to share is favorites, and then for users, I need to share users. Okay? Oops. So to expose those, I go to my config and I say I want to set an entity set access rule. And let's do users first. Now, what I'm setting up here is not, don't think of this as security, think of this as capabilities. This is what the service can do. Okay, so individual users may be able to do less, but they will never be able to do more. So when I say entity set access rights for this one, I'm going to say, well, for users, I only want people to be able to read users through this service. I don't want people to be able to add new users. Okay, so even if I'm an administrator, if I hit this service, I will not be able to add a new user. We'll do the same thing for favorites. We'll make that read as well, but we'll also add some others. We'll say we want to allow insert, so that's write append. We want people to be able to create new favorites. We also want people to be able to update existing favorites and patch those existing favorites as well, or make minor modifications to them. So the two ones we want for that are write merge for patching and write replace for completely updating the thing. Okay, so we've set up our entity set access rights, and I think we are pretty much ready to go. Let me just confirm that I've got this set as my start page, and we'll run this up. And now we're deploying to the emulator on the local machine for Azure, the Azure emulator on the local machine. So that takes a couple of seconds. And we'll just wait for that. While it's doing that, are there any questions so far? No? Okay. So,
I have one.
yes.
Could you go back to the code real quick? I have a reference point. So the type pass to data service, your container, is that a object context?
In this case, yes, it is. Sorry, yes, absolutely. The question is this data source an object context? Because I'm using the entity framework with WCF data services, yes, it is. But I could use different types of data sources as well. Okay?
Use the DB context?
You can do that, yes, with the newer pieces. So the DB context stuff came out after the version of WCF data services that came out with .NET 4. So it didn't know about DB context. There is a CTP out there right now which does know about it, and you can work with that. Even without that, you can kind of work around it by overriding some stuff, and I can show you how to do that if you're interested afterwards. So here's my thing, and the favorite services is underneath this entity framework thing. And so here's the service I've just created, and as you can see, I've got users and favorites. If I click on my metadata, this is what I was talking about before. Clients can look at this, consume it, and generate classes that make it easy to interact with that data. And also, I can query the favorites. And interestingly enough, look at this. I'm looking at the favorites because I'm sharing this data as Atom. Okay, the Internet Explorer shows this in the feed viewer. Now, there's some problems with this. Because I am not mapping any of my fields in my data through to well-known fields in the Atom format, nothing gets shown here. You kind of get this kind of blank screen where you're going, okay, I've got 5 favorites. I don't know anything about them, though. Okay? If I want to see what they look like, we'll fix that up later, by the way. But if I want to see what's actually going on the wire here, I just turn off this feed viewer and run it again, and now we've got our Atom. And you can see here's an entry, and it's got, here are the properties. The reason why none of the information was shown in that feed viewer is because there's nothing in the title, and there's nothing in the summary of the Atom element. Okay, the summary element isn't even there at the moment, but we could have pushed it there. Okay, I can also, write some queries too. So I could write, give me the first page of favorites. So this is just get me the top 2 favorites. Or I could write a filter, and I could say user email address equals and then I just find Pablo's favorites. Okay, so this is the power of OData right there, is that you don't have to think in advance about all the queries that people might want to run against your service. which is one of the major problems with kind of the traditional way of doing service-oriented programming. You'll end up with these kind of functions that you've thought of in advance, so maybe something like get favorite by user ID, but then someone comes along and says, no, I don't want to do it by user ID, I want to do it by email address. And in order for that to work, you have to version your service. But with OData, you don't. Okay, so let's just drop back to this deck for a second and talk about OData and Azure. Okay, so as you saw, I was developing my service in using the Visual Studio, Azure SDK, and tools. So I need that to actually do development. But while I'm doing development and testing, I don't need anything else. But the next level along, I do need an Azure account. When I go in to deploy this thing, I need an Azure account with at least one storage account and at least one hosted service account, which is where I'm going to push my web role to. I need to register a certificate so I can publish my account or my service up into Azure, into the web role. And the way that you do that is Visual Studio makes it easy to create these certificates. You do it by right-clicking on the Azure project and saying Publish, and then it gives you an option to create a new certificate. Once you've created the new certificate, you can't actually say, I want to use that yet, until you've made sure that you've copied the full path to that certificate up to Azure, like this. So you grab that full path, you paste it up into Azure. That puts the certificate into the manageability groups in Azure. Once that's there, you can finish filling this screen in, finish your credentials, and all you need is the subscription ID for your Azure account. You say go OK, and at that point you can publish up into your Azure account. So it's kind of pretty cool. I'm not going to do it right now because it takes about 10 to 15 minutes for it to publish. It takes a while for it to provision a service and so forth. Of course, I've got a SQL Server. I've got Entity Framework sitting over the top of a SQL Server database. I want to do that over the top of an Azure database. So I want my data to be in the cloud as well. So I'd need a SQL Azure database too. And you can see I've got a screenshot here at least of one with called Entity Framework Database. And I'm going to leverage that in a second, and we'll show you what you need to do to change your configuration of your application to use that service. Okay. So let's pop back. In Azure, this is it now live. You can see I've got this place where I can grab my connection strings. This is a connection string which will, if I was writing as just a standard ADO.NET program, I'd be able to use this to connect and write queries and things like that against my database. Because I'm using the Entity Framework has a connection string which contains some other things as well. So you kind of have to put this connection string into part of the Entity Framework connection string. And let me show you that. So in the web config here, if you look, I've got two connection strings. I've got one which is going off to, here it is here, the local SQL Express account. And I've got another one here which is going off to my SQL Azure database. Okay, and the big difference is one supports integrated security, the other one doesn't. So the second one has got my account password in it, so I'm not going to show you that. If you were wondering why I was scrolling slowly to the right, that was why. But what I'm going to do now is I'm just going to swap these connection strings. I'll turn this one off, and I'll turn this one on. I know this is probably not the best way to do this. You're supposed to do this with the different versions of the web config for deployment and so forth, but just to make it easier, I'm going to do it there. If I run my application again now, in fact, before I do that, let's go in and have a look at what I've got in the cloud. Which database am I looking at the moment? Wrong one. I think this one. I'm looking at my Entity Framework database in the cloud, and I'll just delete those guys. Okay, so if I run my service again now, save my changes, run that up. It's going to take a while again. Now, I'm still running the web role in the local emulator, but I'm now connecting to the SQL Azure database in the cloud. Okay, and because, remember, I have some data in my setup database which is going to initialize the thing. So when my application starts up in global ASAX, it's going to push some seed data up into the SQL Azure. So I should see, if I query my favorites, I've still got some data there, even though I just deleted all that stuff from the server. So that's pretty easy. Now, in terms of how did I get my model up into my database? Well, I used the entity framework model first. So if you click on that, here you get the ability to generate the database from the model. If we run that, it produces some DDL. I've already kind of cut and pasted that into this file here. It's got some stuff in here which doesn't work in SQL Azure. You can't do use statements in SQL Azure. But once I'm in the right database, I can do this. So I could just cut and paste this code and run that in here to create my model. Okay, there are other ways you could do this. You could use all the tools that you might be familiar with. If you're familiar with SSIS, you could use that. You could use Juno. There is a let me just go back to the decks. So you could use SSIS. You could script the database, which is kind of what I did, and you could also have some code in your app to initialize or put some seed data into the database. And in SQL Azure Labs, they also have this tool, this import-export tool. It's not available in SQL Azure for real yet, but it will be soon. That allows you to kind of export a database. So you could use this to export your local database that you've been developing with, and then you can publish it up into the server. It's just a command line tool. Okay. So that was how you get your stuff up into SQL Azure. Now let's talk about configuring our application so that it's doing all the right things. Okay, so that we're taking it, not overusing resources, we're not sending too much traffic over the wire, those kind of things. The first thing I want to show you is something called server-driven paging. So server-driven paging, what this means is, imagine if you had a lot of data. With OData, someone can easily walk up and issue a query against that, even through a browser, that says, I want everything from that feed. Now, I'm sure you can imagine that if you've got, say, 200,000 titles, like, say, Netflix, that's a lot of load. You've just asked the server to do a lot of work. Number one, it's got to get all that stuff out of the database. And number two, it's got to serialize all of that stuff over the wire. So there's a lot of bandwidth cost and a lot of CPU cost associated with that. The way we turn that off, or we control that, is the protocol supports something called server-driven paging. And so does WCF Data Services. It makes it very easy to turn it on. So you set a page size. Just like setting entity set access rules, you can do this per feed if you want. Or you can do it across all feeds, and that's what I'm going to do. And I'm going to set my page size. Normally you would set this to something like 100 or 200 records, or somewhere between 100 and 500 records. But just so that we can actually see this in effect, because I've only got 5 favorites, I'm going to set the page size to 3. So that will change how much data the server will send in any one request. And there's some good advantages from that, right? It means that most people, when they ask for the data from the service, they don't really want all of it. They only want enough that they could render on a single page anyway. And it also means that if someone really does want all the data, then they have to issue multiple requests. Okay? Because as a result of this, you'll get a next link which you can follow to get the next page of data. And of course, if someone's issuing lots of requests, that's a great opportunity for you to turn on throttling. Okay? Another thing that's, if you're familiar with the entity framework, you'll be familiar with the idea of expanding your results. And you may even be aware that when you do an expand, so what I'm talking about here is, let's say I'm asking for a user, and I also at the same time want to get back their favorites. That's a kind of an expand. Well, you might be familiar with how the entity framework translates that into SQL. And if you have multiple expands going on simultaneously, you end up with quite a big SQL expression. So there's quite a lot of cost associated with that. So another thing you might want to do is sort of restrict what people can do here. So I might say they can only ever expand one level at a time. And then I could also do, they could only ever expand just one thing at a time. So the difference between the two, depth is how far you can go down. So if it was expanding orders, or expanding a customer, you could expand their orders. That would be one level. And then you could expand the order lines. That would be 2 levels, and so on. Whereas the count is just how many different expands there are in the query. If you remember a little, when we first ran our service and we saw the feed in the feed viewer, we couldn't see any of that data. So let's change that, right? Let's make this so that our data actually gets mapped through to the Atom feed viewer. The way you do that, it depends on which provider you're using, but for Entity Framework, you need to open this up and see the XML, unfortunately. And it's in the conceptual model. So what you need to have this namespace introduced into your conceptual model schema. Once that namespace is available, then you can leverage annotations from that namespace, which tell that WCF data services to do a mapping. So this particular one says that what's this property? This is the name of a favorite should be mapped through to the title element in an Atom feed. Okay, and the next one underneath it says that the summary comes from the description of a favorite. So with those in place, I think it's probably a good time to just run this now and see all of these 3 things in action. Oh, hello. What's that? Oh, did I? Thank you, guys. I'm glad you're onto it. That would have taken me a while. Dum-de-doo. Any questions while we're waiting for it to deploy? Yes?
What is the primary difference between a WCF service contract using the REST implementation versus OData?
Can you ask that question at the end? Because that's a question that needs a bit of time to answer, okay? Okay. Yes?
On the mapping, is there a way to map the hyperlink when you actually click that Atom entry? You know what I mean?
I don't believe so. We can come up afterwards. There are some people in this room who may know more. Let's talk about that afterwards. Okay, so let's have a look at, the first thing we want to see is make sure that server-driven paging is working. So I'm going to go off and look at favorites now. And remember, we set the page size limit to 3. Okay? So hopefully we only get 3 items. We know there are 5 favorites. We only get 3. If you want to get the next lot, you have to issue another request to this next link. And then you get the remaining 2. Okay, so server-driven paging is working. Let's go back to our internet options and turn back on the feed viewer. And rerun this. And now you can see that we've successfully mapped the properties of our data type into the feed elements in Atom. So it means that we've essentially extended the reach of our protocol and make it easier of our service to make it easy to consume in other places. Okay. The next thing I want to do is I'm going to go ahead and add caching support. And I'm going to have to cut and paste a big chunk of code because no one wants to see me write this. That will take me some time. And I'll talk you through what this code is doing. I need to. This code actually, it has a testing method associated with it, which is exposed as an OData service op. So I need to make sure I can actually access that service op. So I'm just going to, just like I exposed entity sets, I'm going to expose this service op. I'll just do a star here, just for the sake of speed, which means that all service ops exposed by this service can be consumed. Okay, essentially what I've done here is I've got this code which is going to run every time someone starts processing a request. Okay, and what it does is it logs the request. So this is just to kind of keep track of a count of how many requests are actually being processed by WCF data services. And the service that I was talking the service operation that I was talking about, it basically just returns that count. So this is how we can see whether the data is being served by WCF data services or by the web server. If it's being served by the web server, it's coming out of the cache. Okay? And the thing that I've done here to make sure that we don't cache the number of counts is turn off caching on that particular request. Okay? So that's kind of like the infrastructure stuff, just so we can see this stuff working. The rest of it is actually the core code. I just call the base processing request because I want that to go through the rest of the WCF data services stack if it gets this far. Then I've got some code here which is saying, hey, is this request changing the data? And the way that I do that, if you look at the isChange, is I'm doing something very draconian in this example. I'm flushing all of my caches whenever I get any change. Okay, but you could do much more targeted things here. So you can see anytime I see a post, merge, put, or delete request, I just flush. That's me saying, okay, something is going to change, so I'm going to kill my output cache. And you can see I clear the output cache there. The way I clear the output cache is by removing an entry from the cache upon which the output cache is dependent. So when I remove it, it says, I can no longer hold on to the output caching. Then actually how I set up the cache in the first time is I go through this code here. And what it does is it grabs the current cache policy, changes it to say that this can be cached on the client and on the server, but not in proxy servers. The reason why I don't want it cached in proxy servers is there may be differences between users. Okay? There may be authentication or authorization logic which has changed the amount of data that goes over the wire for different users. I've set a cache timeout of, here I've said max never expires, but you could make that an hour, 15 minutes, whatever you think is appropriate for your service. And then there's some things that need to change mean that you won't hit an existing item in the cache, right? You don't want everything to collide. By default, it takes the path and says anything which matches this path will go back to the same request. But because WCF Data Services supports content type negotiation via the accept header, we clearly don't want to serve up JSON from the cache if someone is asking for atom. So that's what we're doing here. We're varying our caching based on what's on the server, based on what the request says. So if we need different encoding, we don't serve from the cache the same thing that we needed which was cached with a different encoding. And then this by parameters, that's the query string part. So anything that's different in the query string will not collide. Okay, so that essentially just produces a great big long kind of, like a key into the cache that we can use. And then the final piece that's kind of interesting is I mark that and say that that's dependent on this item that I put into the cache. And this is the thing that I delete when there's a change. Okay, let's run this and see if it works. Okay, so if I run this request here, this is to get some random data, and now I run get process count. You see, data services has processed one request. If I run the same request again, and then let's just delete these other ones, and then run the process count again, you see now why is it process 2? Have I turned something off? Da-na-na! What did I do wrong? Let me just... Actually, let's just try something again, because sometimes I may have... So I'm running this a number of times now. And let's do this. It's still 2. So at least something happened the first time. I'm not sure what it was exactly. I may have actually ran another part of the data services stack by accident. But you can see here that it's now being served again out of the cache for the second time. That's unfortunate. That demo would have been much better if it had returned 1 the first time. Well, you can see that it's working though, right? Okay, so that's caching. Next thing I want to talk about is reach. We need to make sure that we can get our service out to everybody that needs it. So the thing that we need to do here is we need to make sure that people in JavaScript and in Silverlight can access our data service. The way you do that with JavaScript is you need to turn on something called JSON-P. And this slide is going to explain to you what JSON-P is if you don't understand, because I didn't understand it the first time I ran into it either. So imagine you have a site, and it serves up a web page. And that web page has some JavaScript code, which goes and gets some data from the same site. But that will work just fine. But if that web page needs to get data from a different site, then the cross-site scripting will kick in, and the browser will not allow that request to go out. What you have to do instead is you return a page, and then instead of actually directly calling JavaScript to go and retrieve data from another site, you inject a custom script element. And the URL of that script is the page that you want, where the data is that you want to get down. So you just add that script to the page. That script will go off to site 2 and return data. Now notice the difference. The key difference is that you need to have a callback function in the results. Otherwise, you're just getting a script which is just loading some JSON into memory, but you can't access it because there's no placeholder for it. By putting a method in there, that's a method that's previously somewhere else on the page, and that's essentially responding to the fact that you're getting all this JSON back. So that's great. How do we enable it? It's actually incredibly simple. There is a little file you can download from the MSDN code gallery, which adds JSON behavior support. And this is doing some nifty stuff inside WCF with channels and things. I don't think you really need to worry about that. All we need to worry about is how we use it. It's pretty simple. Oh. You just attach the behavior onto your class like that. And once that's done, the data service now supports JSON-P. Okay? In fact, let's just show that working. So I'm just going to start up Fiddler so we can see this request. Fiddler is a tool. It's a great tool if you haven't used it before for kind of monitoring what's happening on the network. So in my client, I'm going to click this URL, which is going to issue a JSON-P request to the server. If I look in Fiddler, I can see the request here. If we look at the raw request that went over the wire, you can... You probably can't see that. Anyway, what it's doing is it's making a request and it's saying, I want the format of this request to be JSON, and it's telling me the callback should be test. So it's saying, I want the function that you call as a test function. If I look at the results, by looking at the raw results, you can see that I've got my JSON, but it's been wrapped in a call to test. Okay. The other thing we need to do to maximize reach of our service is we need to make sure that Silverlight clients that are not hosted on this site can talk to our service. And the way we do that is pretty simple. You just add a client access policy file to your project, which I've already done. Okay? Let's go back and talk about security now. Yes, sorry.
That's my question.
Okay, you're ready for security? Great. So authentication and authorization. Who knows? I mean, if you're like me, you may have seen things like authn and authz for the first time and thought you weren't part of some club who knew what those things meant. Authn is authentication, and authentication is really just figuring out who is making the request. Authorization, or authz, is about figuring out what that person can do. Okay? And the way we typically think about this, imagine you have a data source, and you, of course, you decide you want to expose this using OData. At this point, anybody can do anything that their service is allowed. So remember, we had set up those capabilities right at the start when we set up the entity set access rules. Those are kind of like the capabilities of the service as a whole. Because I've done nothing with my security settings, anybody can do anything. Everybody can do the same amount of things, sorry. The first thing we need to do is figure out who's making the request. We need to authenticate. And the way you do that is with a HTTP module. And the reason why we do it like this is because it's kind of not a concern of the data service. Okay, it's kind of an orthogonal concern. It's something that happens up front. And that module's responsibility is simply to figure out, by looking at things on the request, like headers, authentication headers, session cookies, anything and that depends on the authentication protocol being used, how to find out which principal is currently attempting to access these resources. And its job is to set that, to essentially create that principal and attach it to HTTP context current user. Potentially, yes. Yeah, I mean, we should talk about that because I need to understand that. I'm not an expert in Kerberos, so I don't know its implications on payloads. We need something which is header friendly only. So if Kerberos works through headers, then absolutely. Yep. Okay. So once we know who is actually accessing the site, now we can inject our authorization logic. And our authorization logic, the way you do that in a WCF data service is using query interceptors for queries. So these are quite granular. They are attached to each of the feeds in turn. This means that you set up, and what the query interceptor's job is to essentially filter things that are not applicable to that user or should not be visible to that user. Okay? So for example, if a salesperson comes in and they're from Atlanta, then maybe they should only see customers from Georgia. Likewise, if you want to control what people can update, you do that through a change interceptor. And change interceptors are used to control. They allow you to essentially stop requests or modify the request as an update occurs. So a great example of that would be, hey, I'm a salesperson, I'm trying to create a new supplier, maybe I can't do that, maybe it needs to go through some requisitioning train or something. There's also another way you could do this. You could do this with there's an event in the data service processing pipeline. The problem with that event is a system-wide event, so you can kind of do very broad security and authorization logic there. The problem is you have to work out what's actually happening. Okay? When you're down at the query interceptor level, that work has already been done for you. So we highly recommend doing it through change interceptors and query interceptors. But if you've got kind of like a more advanced scenario and you need to get a little bit, you need to do kind of system-wide security, you can do it at the processing request layer. Let's flick back to the code. And I've got a code snippet which shows you how to inject, which shows some query interceptors. And what we're going to do here is make sure that only certain people can access favorites and users. Need to stop the service again. Come in here. Got to resolve a few things for this one to work. Oh, user. Okay, so I've just added those interceptors now. We've got all our kind of infrastructure in place. And the first one I've got here is one which is a change interceptor over the users set. And you can see I have to create a method, and I have to decorate it with this attribute that says it's a query interceptor over the user's feed. And then I have to return an expression of func of user to bool. So that sounds like a mouthful, but really all that is a is an expression which will filter users. And what I do here is I'm looking at the current request. In this case, I'm looking to see if the request is authenticated. If it's not, then no, you can't get to the users. So I'll throw a 401 here. Then I've got some code which extracts from the current user. The user actually is a principal which has an email address. I can show you that code in a second. So I'm using that to go and look up a user in my entity framework database. Okay, and I don't know if you remember, right at the start we said users may or may not be administrators. And we said that I was an administrator and Pablo wasn't. So right here, if the person is an administrator, then they can see all users. If they are not an administrator, they can't see anything. Got a similar one over here for favorites. This one's a little bit more interesting. If you're not authenticated, this time we don't throw an error. We actually say, hey, well, you can just see the public favorites. If on the other, we do the same search for the user. If the user is an administrator, they can see everything. If, on the other hand, they are not an administrator, but they are authenticated, so we have a user, then they can see public favorites and their own favorites. And we have similar sort of code in change interceptors. Change interceptor logic is a little bit more tricky because you have to know what kinds of requests are coming through, and they all kind of come through the same function. But fundamentally, it's the same principles apply. You kind of work out who's doing what and whether you allow them. Okay, so that's change interceptors. And if we run this code, actually, while that's starting up, just wanted to show you some code I've got here. I've got a little authentication module which I've hooked up through it via the web config file. And this thing is a play authentication provider in that it doesn't really do much. Okay, it says that every request is coming from Pablo unless on the query string there's an admin tag. And if it says admin equals true, then I go, no, it's not Pablo, it's Alex. Okay, so you don't do this. Normally you would have an authentication provider which implements some protocol, maybe OAuth or basic auth or some other authentication scheme. Anyway, but this is going to be useful for us just for demo purposes. So we've got our data now. Now remember, it thinks that everybody that's coming in is Pablo right now. So I get 2 results. So there was 5, I only get 2. That's because it's just giving me the public one and Pablo's own favorite. If, however, I put on the query string admin equals true, I get 3, and if we looked in the results, there'd be a next link as well to get the rest of the results. Okay? So that's the change intercept, that's the query interceptor working right there. If I went to users, it's going to throw an exception in the code, but that would just normally populate right up, and that's like, Pablo, sorry, you can't see all the users. And again, I could put admin on there and I'd be able to see it. Okay, so what is our guidance around authentication? So for authentication, you've got a series of options. If you're on the domain, then Windows authentication is perfect for you. It's simple, it works, and you don't really have to do much. It's all built into IIS and everything, and it just works. If you want to have maximum reach, and that means getting out to clients like Excel and Power Pivot and maybe Tableau and things like that, extra OData clients, then Basic Auth is good today. Right? Basic Auth, though, is a protocol where your username and password go over the wire, not encrypted or anything. They go over the wire encoded. Okay, so you need to use Basic Auth with SSL. You cannot use it without SSL. That would be unless, of course, it's just on a domain and you trust everybody on the domain. Forms authentication. Imagine you have a website that already uses forms authentication. And what you want to do is add to that website an OData service. And the responsibility of that OData service is to share your data with to share the data that the website is using through the OData protocol. That would be a scenario for using Forms Auth. But going forward, we're seeing more and more scenarios for OAuth, or OAuth 2.0 in particular. OAuth is kind of like something that's, this is kind of the general direction of the web, particularly as we head more and more to the cloud. Okay, because you have all these different new types of scenarios that are not supported by basic auth and forms auth and things like that. So let's talk about what those scenarios are. Imagine you have a user and he has an account with either Facebook or Google, for example. You also have a data service in the cloud that you want to allow that user to get to. The way you do this is, well, you know this so far. You put in a HTTP module which implements OAuth, and you have an identity provider. Now, they're both in gray because they trust, or the OAuth module trusts the identity provider. And the way that it does that is they both share a signing key. Okay? So claims made by the identity provider can be verified by the OAuth module. The identity provider can be internal or external, but it needs to trust these other identity providers like Google and Facebook. Okay? The best way to do this today is using App Fabric, access control services, because it makes it incredibly easy to set up these kind of relationships with Google, Yahoo, Facebook, and Live ID. Okay? Now, the way things work here, imagine the user has already attempted to access the data and there was a 401 request because the OAuth module said you're not authenticated. Well, then the user would authenticate against Facebook and give consent. Now, what you're giving consent to here, you're not giving consent for this application to access that user's Facebook data, which is what you might be familiar with from all these kind of Facebook apps. What you're giving consent here is for Facebook to share the identity of the user with the other identity provider. So assuming you've given consent, you'll get something which is trusted from Facebook that says that this is someone at facebook.com. Okay, this is of no use to the OAuth module, though, because it doesn't have that trust relationship. So the identity provider will take that and re-sign it. This time it's in blue because it's been signed by the identity provider. Now that then gets sent in every request that goes to that server. Okay? Think of this, and OAuth supports different access token types. This particular one is what they call a bearer token. So if I have the token, I am that person, or I have the rights of that person. And essentially, because that token has been signed by that identity provider, the OAuth module has the signing key and can take the claims that have been made, like in this case who the user is, and can re-sign it and see if they get the same signature. And if they do, they go, okay, this cookie was signed by someone I trust. Well, this token was signed by someone I trust, therefore that is who this person is. All of this is just to figure out who someone is. Okay? Once you've figured out who they are, then the normal authorization logic flow carries on. Another scenario which OAuth supports is the corporate domain scenario, where a user has an account on a corporate domain and they need to have access to something in the cloud. So again, you have the same sort of setup. This time, the difference is that the identity provider is configured to trust the corporate domain. And usually this is done using Active Directory federation services. That's what you need to help you set up that link. So you use access control services as your identity provider, as the data services identity provider, and Active Directory federation services as the way you bridge the two. So the user tries to authenticate against the corporate domain. Usually that would just use integrated security. Okay, it would just work. At this point, by the way, these arrows are not meant to be accurate. They're meant to show the concepts. Okay, just in case you think, hey, this doesn't look quite right. Okay, these arrows are just to try and explain what's going on. So then we figure out who that person is. We've got a token which says that person is someone from mycorp.com. And then we just do the same exchange. This time it gets re-signed by the identity provider, which is trusted by the OAuth module. And again, we know who the person is that's making the request. And of course, that's the authentication step. And then all the normal authorization logic has to take place after that. Final scenario is delegation. Delegation is where you have a user who has some resources in a service or behind somewhere, and they want to give access to an application to that data. So in this case, the application says, I need access to that guy's data. The identity provider will essentially challenge the user to say, is that okay to log on? So they will authenticate, just using a username and password typically. And then they will give consent. And they're giving consent to that application to do some stuff with their account. The key piece here is it's not, that account is not that account, that application is not going to be running as that user. It's going to be given some claims which tell the data service it can access some of that user's data. This is kind of critical because without that, you would end up in a situation which is kind of like what we've got today and why OAuth has been born, where if you want to have an application access your data, you have to give it your username and password. Which, if that application turns out to be nefarious, is kind of unfortunate because now you've just given them their username and password. They could do things with your account that you don't want them to do. In this particular example, the token just says what the person can do. So it says that, hey, I can read that person's data. Just read. I can't change their password. I can't edit their data. I can't delete their data. And of course, the OAuth module will set that up and share that with the authorization logic. And in the authorization logic, assuming it's been set up correctly, if they get a request from that application to delete some of that data, it won't allow it. And the other thing about OAuth in this scenario is that I can actually revoke permission later, okay? Which is very hard to do with username and passwords. The only way you can do that is by changing your password. Okay, so that's authentication and authorization. Has anybody got any questions about that while we're on it? Yes?
Maybe I missed it. The delegation to multiple database scenario with the OAuth provider. So if you have data spread out across 4 or 5 different connection streams with no data,
Yeah.
how does the provider know which data source to connect to?
So the question is, let me try and restate it, and I think this is what you mean. You're talking about federating data sources into a single data service. Yeah, so if you were going to do that, you would need a custom OData service. WCF Data Services has multiple ways that you can create services. There's the way I've been showing you so far is by far the easiest, which is using Entity Framework. Entity Framework would not support that, so you would need to write a custom provider. And a custom provider, you could write whatever code you need. Okay? Okay, so the last thing I want to leave you with today is about versioning. So this is kind of planning ahead. As we know, someone's going to come along at some point and want to add new fields to your service or add new types to your service and so forth. There are a few things that you can do to make it so that is non-disruptive to your clients. The biggest one of those is if you're using WCF Data Services client, you can say ignore missing properties. That will save you in some scenarios. There's a couple of things that you can safely do, but there's a number of things that you can't do with that. So what this basically boils down to is at the end of the day, the most realistic option that you have when you're putting up an OData service is when you push it into production for the first time, that is version 1. And you keep that alive as long as you need it to support the clients out there that are using that version of the service. If you need to push a new version of the service, it's version 2. And you do that by putting out another URL. Okay. So the talk is over, just about. Just a quick recap on what we've learned today. I think you've learned the easiest way to build a web API which shares data over the web. That's OData. And you've also found the easiest way to host that. And that's using SQL Azure as your database, Azure as your web role or your web server that hosts the data service. We learned how to do it the right way so that we don't waste bandwidth and things like that, or waste or support unnecessarily complex queries. We did that through configuration. We made sure that we could reach the appropriate clients that we needed to reach. We made sure that we could get out to JavaScript clients, Silverlight clients, and so forth. And of course, right at the end, we learn about versioning. So you've just learned how to build a real OData service in the cloud. Thank you.